So in lesson 8, we're going to look at design. So we saw already requirements, spent 3 days on requirements. Then we looked at analysis, making the domain model and finding the responsibilities of the domain classes, the sequence diagram. Yesterday we looked at architecture and we looked at layering and other architecture principles. And then today we look at design, and in design basically you look, how do I get my analysis, my domain model to work in design? So now we go to a database, now we have a user interface, now we do send messages, and now we do logging, now we do something with transactions or security, or we write something to the file system, all kind of technical aspects that you need to get your application working. So we saw yesterday domain-driven design as an architecture style, and there basically the most important thing was that the domain model, that's the heart of your system. So you have this ubiquitous language, the domain model, it's the language that you speak, there are the business rules, that's the heart of the system. So what do we do then in design? That our analysis model, we separated, or our domain model, we separated from all the technical code. So one of the best practices of design principles was separation of concern. And it separates the business logic, your domain, from the technical implementation, from the classes that go to a database, from the classes that write something to the file system, from the classes that do logging. You don't want logging code, sending email code, going to the database code in your domain classes. You want to separate that. And that's what this figure shows, that persistency, you go to the database, other classes, they know how to go to the database, so we have separation of concern and single responsibility. These persistency classes have the responsibility to go to the database. The business logic classes have their own responsibility. These messaging classes, they have the responsibility of sending and receiving messages. These loggers, logging classes, they have the responsibility for logging, wherever you want to log, to the file system or wherever. And here I have classes for remoting. If you want to call our application through messaging or through a REST or a web service, a SOAP or whatever, we have classes to do that. So these blue circles here, the classes in the blue circles, are technical classes. The one in the transparent circle are domain classes. And we want to separate them from each other. So let's see how we do this. So first, design pattern basically, or this one is often called an architecture pattern, but it doesn't matter that much. A data access object, also called a repository. So it's two names for the same thing. A data access object is a class that has all the logic for going to the database. So make a connection to the database, start a transaction, send this SQL to the database, get the result back, do something with the result, whatever it needs to do, commit a transaction, close the database connection, exception handling. That's all in a data access object. So there's logic only for data access, for nothing else. That's the single responsibility. The only sole responsibility, data access. So we have data access objects, and I will give an example, but typically we have a data access object for every domain class we want to put in the database. And I'll come back on that later. But if I have a domain class customer and I want to do something with customer, I have a customer DEO or a customer repository. If I have an order, I have an order DEO and an order repository. If I have a patient, I have a patient data access object. If I have an invoice, I have an invoice data access object. So typically I have many data access objects. And let's take the example of the invoice. The invoice data access object, what are the methods? Well, save an invoice, update an invoice, delete an invoice, find an invoice, so typically different finder methods. Find invoice by invoice number, find invoices by date, find invoices by price. So there are many finder methods, but it's all database access. Then the next one is a gateway. And gateway is used in different ways, but in this case it is a class that knows how to call an external system. So here's my external system, whatever it is. And the logic to call that external system is encapsulated in the gateway. Single responsibility. Its sole responsibility is access that external system. So it knows which URL should I go to. And maybe it has to transform some data so that that system can handle the data. It knows about timeouts. It knows all the details for calling that external system. And typically we can have multiple gateways if we call multiple external systems. And something that has the same idea, we want to send an email. Okay, so we have an email sender. It doesn't call an external system, but it does send an email to an email server. So we have technical classes, data access objects. Here I call it a JMS sender. This could also could be called an email sender. JMS is something in Java to send a message. But what they introduce now is a service class. So yesterday we talked about a controller. Now, I call this now a service class. What is the responsibility of this service class? It has two responsibilities. The first one, it's an entry in a complex subsystem, or a component, or service, however you want to call it. So we saw a component or a service as an interface. Who implements that interface? That's the service class. Now, the best way to explain the service class is it's a reception. So this is a design pattern. In advanced software development, you learn all about design patterns, but one pattern is what they call the facade pattern. The facade pattern, the facade class, is the reception. So let's say we have a large company and they have a large building, and in that building they don't have a reception. So let's say it's a bank and there's a high riser somewhere that's from the bank. And there are all kinds of floors and all kinds of offices where people work, many of them. Now, if there is no reception, then all customers, everybody who has to talk to anybody in the bank, all your external customers, they need to know where to go to when they need a loan, where to go to when they want a mortgage, where to go to when they want to get money, where to go to if they want to, let's say, exchange money. So this customer knows, okay, for a loan, I always go there. And I also sometimes go to exchange money there. This customer always goes there and sometimes goes there. And then there's a big reorganization in the bank. So it's not going so well. So we rent the top 5 floors we rent out to another company. So these people, they have to go somewhere at another office. And it's a big reorganization, so people move to different offices. Some people are laid off. Some people got different jobs. So it's a big reorganization. Now, the only way to do that well is to send a letter or an email to all the external customers, everybody that ever visits that bank. Because now I always went to Frank at office 418, but now Frank doesn't do that anymore, and Mary took it over, and she's now at office 125. So I need to know, first of all, where do I need to go to, and now I talk to Mary. So that's not, basically, if you talk about coupling, there's tight coupling between the external customers and the employees in the bank. So how to solve this? And it's actually very simple. It's a very simple pattern, basically. So here are all the people here. We use reception. Everybody that comes through the front door goes to the reception. So now the external people here, they go to the reception and they ask at the reception, I want a loan. And then they send you somewhere. Let's say here. And now there is a big reorganization. I come again, I say, I want a loan. They say, okay, then you have to go there. So the external people, the outside world, does not depend on the internal structure of the bank. And you can look at it similar as software. This is my component here. In this situation, the external clients of my component have tight coupling with the internal structure of my component. So that's why I have now the facade, that's where I enter. So I don't depend on anything inside this component anymore. You can change anything in the component as long as the interface remains the same, it's no problem. So that's where we talked about components plug and play. It's encapsulated and there's an interface. There's only one way you can come in, and that's through the reception. Well, this facade, this account service here is my reception. So how does it work? The client says to the account service, deposit $100 to account 312. What does the service do? It goes to the account DEO and it says, load accounts with account number 312. It goes to the database, gets all data of account 312. It instantiates an account and puts all account entries in the account. So maybe, what's an account entry? Let's go back here. An account entry is, so if you get your bank statement, maybe online or on paper or whatever, if you get your bank statement, then this is your bank statement, and it typically says somewhere, well, let's say you have $1,000. That's your total amount. But then it has a lot of account entries. You can also call them transactions. You can call them account lines. But here it says, on this date, on January 1, you got, let's say it's your salary, and I don't know what you earn, but let's say $3,000. That's added. And on January 2 at this time, you go to the ATM and you withdraw $50. These are your transactions, and you have many of them. That's what I mean here with an account entry. So in the domain model of the account, I have an account and an account entry. That's my domain model. A simple domain model. So I kept it on purpose. I kept it simple. So when I call load on the account DO, it goes to the database, it gets all the data, it instantiates the account, it instantiates all account entries, adds it to the account because it has a list of account entries, and that's what is returned by the loads method. Then the account service calls deposit. Deposit $100. This is where the business logic is. So we talked about business logic. Business rules are in the domain classes. Here is my business logic, not in the service, here. So the business logic for withdrawal is, for example, how much are you allowed, is your balance allowed to be a negative? So let's say the business rule is you can have a negative balance of $1,000. So whenever you call withdraw, in this method, that is if balance is smaller than the amount that you withdraw, and then minus, how do I say that? At least you check if your balance will not get minus 1,000, and if that's okay, you do the actual withdrawal. Balance is balance minus the amount. In a deposit, maybe there is a business rule, you're not allowed to deposit more than $10,000. That could be a business rule. That's in this method. For every deposit you do, you get certain points. And with these points you can buy products or so. That's in this method. All business logic is in this account and account entry. Account entry probably doesn't have that much business logic, but these are my domain classes. So what does the deposit do? Create a new account entry, set the amount, the date, the description, everything, and then return. So I'm again back in the account service. Then the account service talks to the DEO and says, update this account in a database. The account DEO knows if you give me an account, I know how to put it back in the database. And then maybe here, then you come back, and then the deposit, the account service tells in this case, the GMS sender, let's call it the email sender, we send a message to the account holder, and it will send a message. Now, the idea of a reception is, a reception doesn't do business. So if you go to the reception of a bank, you cannot get money. They don't give you a loan. You cannot exchange money. You cannot get a mortgage. A reception delegates. You come in and they say, oh, go there. You come in and, oh, go there. That's all a reception does. Like in the early days when they had a switchboard operator at a telephone. Somebody puts in plugs, maybe you've seen it sometimes at old movies, that somebody calls up and then they plug the plugs. They delegate you to somewhere else. That's what the account service does. It's a delegator. Remember yesterday we talked about a controller. A controller is a class that takes control. It wants to keep control of everything. It does everything itself. A delegator delegates. doesn't do much itself, but say, okay, you do this, then do this, then do this, then do this. That's different. So this service doesn't ask, give me the balance. So it asks the DEO, give me the balance of the account. Then when it's deposit, I add something, and then I say update in the database, and then I return the balance to the client or something like that. And it does all the business logic. That's a controller. That's not what you want. Why? If you do that, then that controller becomes too complex. Remember when we talked about orchestration and choreography? A controller is an orchestrator. What's the nice thing about orchestration? The process is clear, but it doesn't work well when it becomes large and complex. Then all the code, all the logic is in this controller. Anytime we need to change something, so then we have to update that one controller, and we have to retest everything in that controller. We don't want that. We want choreography. So maybe in the labs, we don't have time to build a full-fledged enterprise application that normally would take a full Scrum team a year to build. And in your lab, it's small, and you have this one class, and it says, give me this, give me that, give me this, give me that, and do this. It's nice, it's clean, works. But now you go to this full-fledged, big, large application. It's built 3 years ago. It's in maintenance already now for 2 years. And many people have worked on it. 10 million lines of code. And if you do it then your controller will have a huge amount of methods. And these methods have 30, 50, hundreds, maybe thousands lines of code. I've seen projects where they do that, and it's not maintainable. It's impossible. So you want a lot of large, simple things instead of a few or one big, complex thing. So this service is a delegator. If this service gets a lot of code, you do something wrong. The real work should be done in these classes here. Technical work in the technical classes, domain logic, domain rules in the domain classes. So that's the first responsibility. The second responsibility, the service class connects the technical classes, I call it plumbing, something technical. So the account DEO and the GMS sender or the email sender are technical classes with the business logic, the domain classes. So the idea here is, we saw it yesterday, the domain classes, they are not aware, they have no coupling to any technical class. They don't know if there is a database. They don't know if we send messages. They don't know if we do logging. They just don't know. So we want to keep them separate. That makes them easy to test, easy to understand. If technology changes, then it's easy. We only change the technical classes, not the business logic classes. If we start using a new framework, we can just pick up these domain classes and use them in the new framework, because typically these technical classes use frameworks like Spring or Hibernate or message senders and logging frameworks and all that stuff. But that's not in my domain classes. So who connects them together? That's my account service. That's where I come in, and the account service says, first do this, then do this, then do this, then do that. So here I get the same class diagram, but now we get a service layer here. So here's my presentation layer. Here is my MVC stuff. Here is maybe my REST controller. Here is my message receiver. This is how from externally I can call my system. Or here is maybe if you use JavaFX or Swing or whatever, all that logic is here. It's presentation logic. It's about windows and buttons and validation and conversion for the presentation layer. Presentation layer talks to the service layer. It's the reception. Here's where you come in, service layer. Service layer delegates to the other classes. So all the DEOs or repositories go to the data access layer. Here my GMS sender is in the integration layer. And then my business logic here is in my business logic or domain layer. That's the same thing, business logic or domain. So we typically have multiple data access objects here. In the integration layer we have a GMS sender, we have an email sender, here are the gateways to call other systems. Maybe we have a logger that typically also goes here. And we have typically multiple service classes. So this is the account service. Well, if this is a bank application, typically we also would have a customer service with all the logic for customer. Create a customer, update customer information. We also might have a service for stock trading. Let's say this bank, you can also trade stocks. So we have maybe a stock portfolio service. Get my portfolio, maybe update the portfolio, buy stock, sell stock, methods on that portfolio service. And then if we look at the sequence diagram here, if I call deposit on the account service, then it first goes to the account DO and says, load the account with this account number. What does the account DO do? It returns the account. So this load returns the account, my domain account. So then I call deposit on that account. It will create an account entry, adds it to the list, and then says save or update this account in the database, and then say send a message. If it also is a requirement, we have to log every action on an account, then the account service will call a logger and say log this in a file system. That's the idea. So what you actually do is the following. So now in design, we get layers. I want to do it like this. So in design, we get layers. And where is our domain class diagram that we've drawn before? That's here. It remains exactly the same as we designed it in analysis. This is my domain classes with all the domain logic. Now what I add now in design are technical classes. So now we get here all kind of technical classes, get all kind of data access objects, we get multiple service classes, and then maybe some classes here. So we add technical classes, but they are outside our domain model. So they are also outside, the domain classes don't know that these classes exist. Then, in our analysis sequence diagram, it looked like this. So let's go back to this color here. In analysis, we had an actor, we had a boundary, and we had domain objects. And then we created a nice sequence diagram out of it. So now what I'm going to do, so in design, now I have technical classes. So now I have to explain or communicate or discover how this design works, so I can make sequence diagrams of my design. Meaning, now I add technical classes to my sequence diagram. The logger, the email sender, the data access object, the service. So here is now my service. Yeah, this is my service here. So I leave my boundary still the user interface, so I do the same as I did in my analysis, but the boundary will talk to the service. Boundary can only talk to the service, that's my reception. It's the only class the boundary knows. It says do this. Then the service will typically first say to the DEO, load this from the database. It will come back with domain classes, and then it will say, do this. And then whatever we designed in the sequence diagram of the domain should remain the same. That's how my domain works. Maybe I have something like this. And then finally this method returns, and then it also does something here, so it's technical and it does something here, and then we return here, and then we show something in the boundary. That's what you do in design. So you add technical objects, but the analysis diagram, and so the class and the sequence diagram, the structure and how it should behave, should remain the same. There can be small differences depending on what you had in your analysis domain model. So if you remember well, in the exercise from yesterday, the web shop, at the end we had to send an email to the customer that placed an order. Well, in the domain model, we didn't have an email sender. Now in design, we get an email sender. So we have to change a little bit that somebody needs to call the service needs to call the email sender and say, send this email. And the email sender knows how to do it. That's also not business logic, sending an email. This is what you do. So I add technical objects or classes, and then the design model should not change the analysis model, not much. So here is my analysis sequence diagram of checking in a book. We've seen this not yesterday, but the day before. So I scan the library card, then I get the member details and I show it. Scan the book, say, okay, scan the book, and I say to the book catalog, check in the book with this scan code. It finds the book, or the book copy, and then says to the book copy, check yourself in. The book copy says to its connected loan, check in, and it will calculate the fee. So the loan has the checkout date, the check-in date and time, and can calculate the fee. This is from analysis. But in design, we have to get it to work. We should be able to give the design to a developer, and she should be able to implement this. So here, this one, get member details. How does this library get member details? Well, Now we have a database, so we get the member details from this library card has a certain scan code. So we come in with a scan code. How do I get the member details with the scan code? I'll go to the database and do a query, give me all the member details with the library member with the scan code. So we will need to have a service class that goes to a library member DEO and say load library member data. Here it is similar. The boundary says to the book catalog, check in book, and it come in with the scan code of the book, says find book copy. How do we find a book copy? Well, go to the database and get the book copy with that scan code. So now we go to design. This is my analysis. Now we go to design. So what I change is exactly this one and this one. So now what I add is a library service. So my boundary talks to the service, and the service talks to all the other classes. And I get here a library member DEO, a book copy DEO, and a loan DEO. So now you really, sequence diagrams is nothing different than programming. You just program, only at a little bit higher level. You don't implement the methods, but it's exactly the same. So if you have to program here the method scan library card on a library service, you say, okay, I have to show member details. There's no business logic, it's just plain data. Okay, then the service goes to the library member DEO and it says, get library member, or typically it will say load with a scan code. What does the library member DEO do? Goes to the database, gets back the data, instantiates a library member, gives that library member class to the service returns that to the boundary, and the boundary shows the library member information. Then, scan book, we have check-in book with the scan code. First we need to get the book copy. So we go to the database, in this case the book copy DEO. It says, give me the book copy, give me the data of the book copy with this scan code. So it returns a book copy. Connected to that book copy is the loan. So it gets book copy data, loan data, instantiate the objects, connect them together, and that's what is returned. Then the library service then calls check-in on the book copy. This piece here is something we had already in analysis. That's similar as what we have here. So call 9, 10, and 11 is here, also 9, 10, and 11. That's what we want. The analysis model, the domain model should remain the same. So here are all the business rules to calculate the fee, or business rules for checking in a book copy. But we changed now the loan. So we get the loan from the database, it's connected to the book copy. We set now the check-in date. We calculate the fee, and maybe the fee is changed. So then we have to update it again in the database, otherwise our loan is lost. So after this is done, the check-in, the service has to go to the loan DEO and says, update this loan. We don't have to update the book copy, so you don't do it to the book copy. It's only the loan that needs to be updated. So you go to the loan DEO, update this loan. This is now our design. So what will happen if we say, well, if somebody returns a book, send that person a WhatsApp message. Okay, then we have an extra technical class that's a WhatsApp sender. And then the service will say to the WhatsApp sender, send a WhatsApp message. It could be that the that there is a requirement. Everything you do on a database, write it to a log file. So we add a technical class here, which is the logger. And the DEOs call the logger whenever you call a method on a DEO. For all three of them, they call the logger and say log this. So it is for these plumbing classes okay to call each other, but not for the domain classes, in this case the book copy and the loan. They are not aware that there are technical classes. So this is what you do in design. Add a service class, add technical classes, connect them together, make sure your domain model remains the same, doesn't have a lot of changes, and then you use the layers here where all these classes should go in here, the different layers. This is now my design class diagram, and I have design sequence diagrams.